This is Fluid Coding and AI. Today we are stress testing repo-maintenance agents with the parts toy demos usually avoid, Postgres or Redis, a private API, a long build, and sessions that have to resume later. Same repo, same maintenance agent, 3 execution models. The important question is not, which sandbox is best? It is, where does the state go? If the agent installs dependencies, starts Redis, calls a private policy API, writes logs, and comes back tomorrow, the architecture has to answer for every file, token, trace, process, and network request. That is the comparison that matters. Here is the test case. The agent works on a repository with a maintenance task, update dependencies, run a build, run tests, inspect a migration or cache-backed workflow, and produce a report that could become a pull request. It needs a database or Redis. It needs a private API for policy or issue metadata. The build is long enough that a cold start hurts. And the job does not finish cleanly in one sitting, so the second session has to understand what happened in the first. Toy sandbox demos usually avoid the hard parts. They run one command, print a result, and throw the environment away. A real repo maintenance agent is different. It touches package caches, build artifacts, test databases, shell history, command output, generated files, and sometimes credentials. If you only ask whether the task passed, you miss the operational question. Could you replay what the agent did, prove what it could not reach, and delete the right state afterward? The ephemeral sandbox is the clean room pattern. Each run starts fresh, or close to fresh. Files disappear when the run ends unless you copy them out, upload artifacts, commit a patch, or save a snapshot. That is useful for untrusted execution and CI-like checks. It also forces discipline. But the cost shows up quickly. If every session has to reinstall packages, reseed Postgres, warm caches, and rediscover the repo, iteration gets slow and expensive. Ephemeral does not automatically mean safe. If a raw API key is placed in the environment and outbound network access is wide open, the agent can still leak it before the file system disappears. The sandbox dying later does not undo a bad request. So the inspection checklist is simple. What secrets entered the process, what domains were reachable, what stout and steer captured, and which artifacts were exported before deletion. The persistent sandbox is the developer workstation pattern. The repo stays there. Dependency caches stay warm. Build outputs can survive. A local Postgres or Redis service can keep seeded data across sessions depending on the platform. That makes persistent sandboxes a strong fit for long builds, multi-step debugging, and human handoff. Daytona documents file system persistence after stop. Depot describes resumable agent context, and Kubernetes agent sandbox is explicitly stateful with optional persistent storage. Persistence is convenient because it remembers. That is also the risk. A persistent workspace can accumulate .env files, shell history, cache tokens, old logs, database dumps, generated reports, and half-finished patches. None of that is automatically wrong. A persistent sandbox with vault-backed credentials, network policies, time limits, and audit logs may be safer than a disposable sandbox with broad secrets and no trace. But persistence changes the cleanup problem from delete the run to govern the workspace. Vercel Sandbox is a different shape. The docs describe short-lived isolated Linux environments for untrusted code, AI-generated scripts, testing, and command execution. When a sandbox is created, Vercel provisions a Firecracker micro-VM with a private file system, process isolation, and its own network namespace. The environment starts clean or from a snapshot, runs Amazon Linux 2023, has root access for package installation, and auto-terminates after a configurable timeout. The Vercel state boundary is intentionally disposable. File system data is destroyed when the sandbox stops unless you take a snapshot. Vercel recommends external databases or object storage for long-term persistence. That matters for Postgres and Redis. You can seed state inside a sandbox for a test run or restore from a prepared snapshot. But if the maintenance agent needs durable database state across many sessions, external state is usually the cleaner design. Claude Managed Agents adds a managed agent harness around the work. Anthropic describes it as a configurable harness for long-running and asynchronous sessions. The developer defines the model, system prompt, tools, MCP servers, and skills. The core concepts are agent, environment, session, and events. The session event stream exposes progress, tool calls, results, and state. The console can show chronological traces, token usage, and tool execution details. The crucial detail is that managed agent sessions are stateful. Anthropic says idle sessions preserve conversation history, checkpoint sandbox state, and keep file system, installed packages, and created files. Checkpoints are preserved for 30 days after last activity. That is useful for repeated sessions. But it also means data retention matters. Anthropic says managed agents is not eligible for zero data retention because sessions are stateful resources, and transcripts persist until deletion. Self-hosted managed agents splits responsibility. Anthropic still handles orchestration, session state, and the managed agent loop. The execution environment moves into infrastructure controlled by the developer or organization. In Anthropic's worker model, work is queued. A worker claims it, spawns an execution context, downloads skills, runs tool calls locally, and posts results back. That split is why this model is interesting for private APIs and internal services. Vercel announced Claude Managed Agents with Vercel Sandbox on May 18, 2026. The split is clear. Anthropic runs the managed agent loop, model, tools, and session state. Vercel runs the execution environment. Vercel's reference design uses a control plane that receives Anthropic webhooks, then starts one Vercel Sandbox per session. The compute side attaches to the session event stream, runs tools like shell commands and file reads, posts results back, and exits when the session ends. For the private API test, the most important feature is not just isolation. It is credential handling and egress control. Vercel Sandbox supports allow all, deny all, and user-defined network allow lists that can change while the sandbox is running. Its credential brokering can inject credentials into outbound traffic, so secrets do not have to enter the sandbox scope. Vercel says those credential transformations are available to pro and enterprise users. That is a meaningful improvement over dropping a long-lived API key into an environment variable. Now compare logs. In an ephemeral sandbox, logs often mean command output and harness logs that must be captured before the environment disappears. In a persistent sandbox, logs and terminal history may remain in the workspace or provider UI, which helps debugging but increases what must be governed. With managed agents, the event stream and console trace become a first-class record of messages, tool calls, token usage, and execution details. Vercel's control plane can also produce function logs and command output. Containers are where the patterns diverge. Persistent environments are the natural fit when your repo expects Docker Compose, dev containers, local Postgres, local Redis, and long-lived volumes. Vercel's own comparison says Vercel Sandbox treats executions as disposable, while Code Sandbox treats each execution as the start of a longer session where file system and running processes can resume. The same comparison notes Code Sandbox support for Dockerfile, Docker Compose, and dev containers. So for a database-heavy repo, do not hide the container question. The long build is the productivity test. Ephemeral runs pay the set of costs unless the platform gives you a base image, dependency cache, or snapshot. Persistent sandboxes keep the cache close to the work, so repeated debugging gets easier. Vercel has public snapshot work here. In one first-party blog post, Vercel says P75 snapshot restores were over 40 seconds, then reduced to under 1 second through parallelization and local caching. That is snapshot restore evidence, not an end-to-end agent benchmark. Sandboxing limits blast radius, but it does not solve agent behavior. Anthropic's auto mode article names risky actions like crossing trust boundaries, scanning credential stores, sending data to unspecified services, pushing to main, and modifying shared resources. It also reports first-party classifier results, including a 0.4% false positive rate on 10,000 real internal samples, and miss rates on real overeager actions and synthetic exfiltration samples. The lesson is narrow but important. Permissions, traces, and human review still matter. Independent research points in the same direction. Overeager Bench measured out-of-scope actions on benign coding tasks across coding agent frameworks and base models. The paper reports that a permissive framework cluster had overeager rates from 5.4% to 27.7%, while an asked to continue cluster sat from 0.2% to 4.5%. That does not rank these sandbox products. It supports the design principle. The harness and permission model matter as much as the execution box. For this repo maintenance agent, inspect the same things every time. Where is the repo? Where are temp files? Where's the Postgres or Redis data directory? Are secrets visible in .env files, shell history, logs, or tool outputs? Which outbound domains were contacted? Which artifacts survived? Stop, resume, snapshot, archive, or delete? And can you replay the agent's tool calls without trusting a summary? If you cannot answer those questions, the sandbox name did not tell you enough. Here is the practical verdict. Use Ephemeral Sandboxes for one-shot untrusted execution, quick evaluations, and CI-like runs where repeating setup is acceptable. Use persistent sandboxes when the agent needs a full development environment, local services, large dependency caches, repeated debugging, or human handoff. Use Claude Managed Agents backed by Vercel Sandbox when you want Anthropic's managed session and event system, but you need execution near private APIs with Vercel's egress controls and credential brokering. The winner is the boundary that matches the job. The lesson is not that persistent is reckless, ephemeral is safe, or managed agents magically solve security. The lesson is that databases, private APIs, long builds, and repeated sessions expose hidden state boundaries. Before you trust a repo maintenance agent, make the architecture answer 5 questions. What persisted? What was deleted? What was logged? What could reach the network? And what could reach the network? And what credentials entered the agent's world? That is the audit trail that turns a demo into an operating model. If this helped you think more clearly about agent sandboxes, like the video and subscribe to Fluid Coding and AI. More practical agent architecture breakdowns are coming next.